Welcome you all to my YouTube channel. This YouTube channel is for ICSE high school level physics. You will get different videos of physics related to ICSE syllabus. Today in my video, I am going to elaborate a topic related to class 8 ICSE, which is physical quantity and measurement. It is the part 1, and very soon I'll come with part 2 with some more points, some more terms, some more aspects of this physical quantity and measurement. In my video, I am giving emphasis on one physical quantity, that is density, and different aspects related to this density. Let's start our video, physical quantity and measurement. First thing to know, what is a physical quantity? Physical quantity is that which can be measured directly or can be derived or calculated by using a formula. Means two type of physical quantity we are having. One is fundamental quantity. Fundamental quantity which is independent, which can be measured directly, which is having no relation with any other quantity. Second is a derived quantity. Derived quantity means by the help of a fundamental quantity, we can calculate, we can derive, that is derived quantity. So, in physical quantity which can be measured directly by using instrument or can be calculated or derived by using formula, that is a physical quantity. Length, mass, speed, velocity, time, all are the physical quantity. So here we are going to discuss about one physical quantity, which is density. Head, affection, love, these all are sensations, these all are feelings which cannot be measured. So we are not taking them as the physical quantity. So what is that measurement means that? Our topic is physical quantity and measurement. So measurement means what? Measurement is the comparison. When we are having a known quantity and a known quantity, I want to measure the distance between any two point, or I want to know the mass of a given body. When we are going to vegetable market or fruit market, you might have seen one side that seller, fruit seller, vegetable seller will keep a known object and one side a fixed object. And the pointer, when it will come to the middle portion or when the pointer will balance both the pen, will say that is the perfect measurement. So measurement is the comparison between an unknown quantity with a standard known quantity of same kind. So for that measurement, which standard quantity used is called unit, because all physical quantity having a definite unit. Physical quantity having two parts. Here you can see the mass of this man is 87.5 kg. Here 87 is the number, numerical part. Kg is the unit. So every physical quantity is the product of one numerical value, a number, and unit or standard, or with which we'll compare. So physical quantity is which can be measured directly by instrument or can be derived or calculated. Measurement is a comparison. Now, when we'll come to that physical quantity, what we are going to discuss in our video in detail is the density. Here you will see one symbol use. It is rho, a Greek word, a Greek letter rho. Density is a physical quantity denoted by a letter or symbol. It is Greek letter rho. So before going to density, we must have to know about more two quantity. First one is the mass. So what we can say is the mass. Mass is the quantity of matter. Mass is the amount of particle contained in a body. Mass means we know that all the matter made of particles. Number of particles present inside a matter, or the amount of particle present inside the matter, that's what you can say is the mass. Mass having the SI unit kg. Mass having the CGS unit gram. Mass can be measured by physical balance, beam balance, and nowadays we are using electronic weighing machine. Means we can measure by using physical balance, beam balance, or electronic weighing machine. So here is the relationship between CGS unit and SI unit of mass. 1 kg. Kg is the SI unit. Gram is the CGS unit. 1 kg equal to 1000 gram or 1 gram equal to 1 by 1000 kg. It will come to the next physical quantity, that is volume. So before going to the volume, let to know another term that is called weight. Here you can see weight. Mass is the quantity of matter contained in a body. Weight is the gravitational force acting on a body by which earth pull any object to any matter or to any substance towards the center. That's what you can say as the weight. Weight is proportional to mass, means more the mass, more the weight. That is, when acceleration due to gravity remain constant, means a definite place, it will take the place constant, it will keep the location constant, that time weight is directly proportional to mass. Mass never becomes zero, but weight can be zero when it go to space. That condition is called weightlessness. Means weight and mass directly proportional to each other when acceleration due to gravity remain constant, when the location remain constant, when the place remain constant. So next thing, the volume. When all the quantity of matter, amount of matter or amount of particle you can stack all together, where will keep? They need some space. So that space occupied by any object is called the volume. Means for all the particle, how much space taken? That is volume. This volume having SI unit meter cube, CGS unit cm cube. And if we look the relationship between meter cube and cm cube, here it is 1 meter cube equal to 1 having 60 cm cube or 10 to the power 6 cm cube. Why? Why it is like this? 1 meter cube. Meter cube means 1 meter into 1 meter into 1 meter. Means same quantity or same number if we multiply 3 times, that is cube. 1 meter equal to 100 cm. So 100 cm into 100 cm into 100 cm equal to 1 having 60 cm cube. So this is the relationship between meter cube and cm cube. But when you come to the liquid one, in liquid case, we are having the unit milliliter and liter, and 1 liter equal to 1000 milliliter. So next one, the density term. Density, mass per unit volume, amount of matter contained in a given space, how much closely or loosely packed, all the matter packed inside a matter, all the particle packed inside a matter. That's what you can say as the density. So density is the mass per unit volume, means in a given space how much number of particle present, that is called density. Density having the mathematical formula density having the symbol rho, mass m and volume v. So rho equal to m by v or density equal to mass by volume. It will come to their unit. Then unit if we look, mass having the SI unit kg, mass having the SI unit kg, and our volume having the SI unit meter cube. So kg by meter cube or kg per meter cube. And it will come to CGS unit, gram by cm cube or gram per cm cube. It will come to the relation 1 gram per cm cube equal to 1000 kg per meter cube. This is the unit for density. Now we'll look how to calculate density of a regular solid, irregular solid or liquid. First one, if we look here, density of a regular solid. What is a regular solid means? Regular solid means which is having a definite shape. And definite shape solid if we take, we can calculate their volume by using definite formula. Because all the three-dimensional objects are having certain formula to calculate their volume. So first thing to know that density equal to mass by volume means density equal to mass by volume means what? Rho equal to m by v. That means when volume remain constant with the increase in mass, density increase. Means in a certain space, if number of particles increase here, density is more. If number of particles less here, that time the density is less. That means density is directly proportional to mass, whereas If we'll come to the volume, means if number of particles is 100 particles present in this much space and same 100 particles present in this much space. Once the space increase, now the particle is loosely packed. That means density is less. Means density directly proportional to mass, whereas inversely proportional to volume. With the increase in volume, density decrease. That's what it is here. If we look in this point, with the increase in temperature, when temperature increase, inside the particle, kinetic energy increase, because of which they will occupy now more space. Means with the increase in temperature, volume increase, and because volume is inversely proportional to density, density decrease. With the increase in volume, density decrease. That means what we got now? Temperature is inversely proportional to density. With the increase in density, with the increase in temperature, sorry, with the increase in temperature, density decrease. With the decrease in temperature, density increase. Next, it will come to the comparison of density in solid, liquid and gas. We know solid particles are very closely packed. Means all the particles are in less space. Because solid particles are very closely packed, so their volume minimum and density maximum. And when it comes to liquid, in liquid, particles are little loosely packed. So they are having volume more than solid and density less than solid. And if we come to gas, gas particles are very loosely packed. That is the reason that they are having the density minimum, maximum volume, minimum density. But this relation or this maximum volume, minimum density, minimum volume, maximum density is not true for all. If we take some exceptional cases here, mercury is a liquid but having the density more than iron, more than aluminium. And if we will take bromine or liquid non-metal, bromine liquid but has the density more than aluminium. That means some liquid are also having more density in compared to solid. This is the exceptional cases, but maximum solids are having the more density in compared to liquid. Now is the time to calculate or to know how to calculate the density of a regular solid. As we have discussed earlier, regular solid means which is having a definite shape. To find the density, first thing we have to calculate or we have to measure their mass, because mass directly we cannot calculate. We are having the instruments, we are having physical balance, we are having beam balance, we are having electronic weighing machine by which we can will measure the mass of a regular solid. So first thing what we'll do, we'll measure the mass of a given regular solid by using beam balance or physical balance. But most of the time we are taking physical balance, because physical balance keep the accurate measurement, because always physical balance kept inside a glass case. Second thing, to measure their volume. If we want to find their volume for a regular shape, we are having different formula. If we take cuboid, length, like cuboid means like our pencil box, it is length into breadth into height. But if we take a cube, length, breadth and height, all three are same. For that reason they are having the formula side into side into side. In case of cylinder or cylindrical object, we are having the formula for cylinder we are having the formula pi r square h. For sphere, in short foot, cricket ball, tennis ball, that time we are using the formula 4 by 3 pi r cube. Means first thing we got mass by using physical balance or beam balance or electronic weighing machine. Second, we got the volume by using formula. Third, we'll calculate the density by taking the ratio of mass and volume. Mass by volume, we can calculate the density of a regular solid. But when we'll come to the irregular solid, that time it is change, because irregular solid case we cannot take the formula. Before going to that all, let to know the relationship between our SI unit of density and CGS unit of density. 1 kg per meter cube. 1 kg per meter cube means what? 1 kg by 1 meter cube. 1 kg means 1000 gram. 1 meter cube means 1 having 60 cm cube. Here 30 will cancel and we'll get 1 by 1000 gram per cm cube. Means 1 kg per meter cube equal to 1 by 1000 gram per cm cube. If we take the reverse then, 1 gram per cm cube equal to 1000 kg per meter cube. That is the relationship between SI unit and CGS unit of density. Next thing. Now, to measure or to calculate density of a irregular solid. But for irregular solid, we have to take the help of displacement method. So we need some instrument by which we can measure the volume of liquid. So the vessels used for measuring the volume of liquid, first thing, we are having measuring cylinder. Measuring cylinder, it is coming of different capacity. Starting from 0 mark here, it is going up to 100 ml, 200 ml, 250, 300, 400 ml, up to 500 or 1 liter. Here, we'll start from 0 and it is graduated with certain calibration, means 0, 10, 20 like this we can go, or 0, 50, 100 like this. Also it is some measuring cylinder they are having. 0, 1, 2, 3, 4 also some measuring cylinder are having. So it is starting from the 0 mark. We want to measure some more volume of liquid. That time we are taking the help of measuring beaker. That case we can measure 250 ml, we can measure 500 ml. So another one vessel also we are using where it is of fixed volume. That is called a Eureka can. Eureka can time. Eureka can is used to measure the volume of liquid, but Eureka can is little bit different in compared to measuring cylinder and measuring beaker. In case of Eureka can, here it is having a spout. Spout means an outlet pipe or overflow pipe we can say. Means if this vessel is full with any liquid, then extra amount of liquid will come out through this spout, through this opening part. So this is the outlet pipe we can say, or overflow pipe we can say. Means here it will keep a measuring cylinder. We can find out the volume of a given solid. That one we'll discuss after some time. Here, these all are the vessels used to measure liquid volume in liter or milliliter. 1 milliliter is equal to 1 cm cube. Means 1 liter equal to 1000 ml. Means 1 liter equal to 1000 cm cube. Means we can convert cm cube to milliliter, cm cube to liter also. Now, we'll find the density of an irregular solid. Means any shape which is not having a definite shape. For density we need two things. One is the mass, second is volume. First thing we'll calculate their mass. Mass how we'll measure? Mass we can measure by using physical balance, beam balance or electronic weighing machine. So next thing to know about the volume of this irregular solid. To know the volume, we are using displacement method. Most of the time we are using water displacement method. What is the displacement method? First, we'll take one measuring cylinder with certain amount of liquid inside it. It is called initial level. Then keep the object inside. Once the object will go inside, water level will rise. Up to which level water will come, that is called final level. So this final level with the object, initial level without object. So final level minus initial level will able to know about the volume of this given object. Or we can use another method by using our Eureka can. Eureka can it will use in that first we'll keep the liquid up to the top, up to the full line, then we'll keep the object inside. Once the object will go inside, liquid will rise. That liquid when it will rise through the spout, it will come out. And here we'll kept one measuring cylinder. So how much amount of liquid will come inside? That is the volume of this irregular solid. So irregular solid volume also we can measure by using Eureka can. Next thing. Now we got the, in case of measuring cylinder, we got one final level, one initial level. So final level minus initial level equal to, we'll get the volume. So mass of that object by volume of object will get the density. Next thing. To find now the density of a liquid. Density of liquid means, density of liquid case, volume we can measure directly by using measuring cylinder, measuring beaker or Eureka can. Next thing, to measure the mass of a liquid. To measure the mass of liquid, first thing you have to take a empty beaker. Here you can see one empty beaker, and you have to measure the mass of this empty beaker. So after measuring the mass of empty bottle or empty beaker, we'll fill this beaker with certain amount of liquid. How much we want to take. Here the volume, we'll able to know of the liquid volume we got. Next thing to get the mass. Mass of empty bottle we got. Mass of bottle with the liquid we got. Next, we have to subtract now. Subtract means what we'll do now? In case to find the mass of beaker with liquid minus mass of empty beaker. So mass of beaker with liquid minus mass of empty beaker equal to the mass of liquid. Means mass of liquid we got and volume of liquid you got. So we can calculate density of the liquid by taking mass of liquid and volume of liquid. So next discuss now another one. The comparison between the density, which is called relative density. Comparison with which one? Comparison with water. And this liquid or this solid is more denser than, heavier than water, or less denser or lighter than water. That's what we are going to discuss here. That is called relative density. Relative density is a ratio between density of a substance to density of water at 4 degrees Celsius. Means how much time it is heavier or lighter than water, that we are going to discuss here. We will take the ratio time. When we will take the ratio, by this we will able to know it is denser or more denser or less denser than water. So why we have taken 4 degrees Celsius? Why not any other temperature? Because if we look here, water has minimum volume and maximum density at 4 degrees Celsius. That is 1 gram per cm cube or 1000 kg per meter cube. Means 1 gram per cm cube or 1000 kg per meter cube. That is the density of water at 4 degrees Celsius. And it is the maximum. Because water has another property, anomalous expansion, that we will read in our heat chapter. Next, when two liquid, let it be mercury and water, both are 1 liter, both are having volume same, then also we can calculate their relative density. Density is that time the ratio of mass of mercury by mass of water. Means if volume same, mass ratio will give the relative density. If volume and mass both are different, we can calculate density of substance to density of water at 4 degrees Celsius. We will come to unit. Relative density is a ratio, and ratio anytime also not having the unit. Means relative density is not having any unit because the ratio. By relative density, then what we will able to know? Relative density will show us that how much time this given substance is heavier or lighter than water at 4 degrees Celsius. Means it is heavier than water or lighter than water. Let us take some example by which we will able to know what is the relative density actually means. So let us take here one example. First one. Relative density of iron 7.86. Relative density of iron 7.86 means what? That means iron is 7.86 times heavier than water, or density of iron is 7.86 times more than density of water at 4 degrees Celsius. Next one. If we take another example here. If relative density given, how to find density? Look. If it is given to us, density of glass is 2.5 gram per cm cube. This is the density. We have to find relative density. Then what we'll do? Density of water 1 gram per cm cube. Density of glass 2.5 gram per cm cube. So 2.5 by 1 equal to how much we got relative density? 2.5. Means relative density equal to density of a substance by density of water at 4 degree Celsius. If we take another example, here you can see one more example. Density of mercury 13,600 kg per meter cube. But density of water at 4 degrees Celsius how much? 1000 kg per meter cube. So 13,600 kg per meter cube by 1000 kg per meter cube. And in a numerical problem, calculation time, no need of any unit. So for that reason, only we'll write the number 13,600 divided by 1000 is equal to 13.6, means mercury is 13.6 times heavier than water. So this all about relative density, and the calculation. If relative density given, how to find density? If density is given, how to find relative density? Next thing to know, the specific gravity bottle, relative density bottle. Relative density bottle is a specially designed bottle which is having a fixed volume. Means here volume for liquid and fast liquid, and volume for a given substance, we can say given liquid, you can say, and volume of water same, because we are taking same bottle. This bottle is used to find density also, density of a liquid, what we have calculated by taking a beaker, and this one also used to find the relative density. So this bottle name is called specific gravity bottle or relative density bottle, a specially designed bottle which is used to measure the density or calculate the density or relative density of a liquid. This bottle has a fixed volume. So how to find relative density or density? Before some time we have discussed how to find the density of a liquid. Means, and also we got for same mass of for same volume of liquid, how to find relative density. Here, because we are using same bottle for a given liquid and for water. For that reason, their mass ratio will get the relative density, or we can take another process also. We'll take the mass of empty specific gravity bottle, mass of specific gravity bottle with a given substance. Now we'll get the mass of the bottle with liquid minus mass of empty bottle, or empty specific gravity bottle. We'll get the mass of this liquid minus, mass we got, and mass of liquid by volume of this specific gravity bottle. Mass of liquid by volume of liquid, we got the density. So after getting the density of liquid, if we divide by 1 gram per cm cube, we'll get relative density. If it is in meter cube and kg or kg per meter cube density, we can divide by 1000 to get the relative density. So relative density is a comparison. Relative density only to know it is heavier or lighter than water. So this all we have discussed today. What is physical quantity? What is measurement? Density. Density comparison in different states of matter. How to get relative density? How to convert relative? If we know the relative density, how to get density? And if we know the density, how to find relative density? So in my next video, I'll come very soon to give you the knowledge about law of flotation, in which condition a body will float or sink, and also by using the relation density equal to mass by volume, I'll solve some numerical problem for you. To get some more videos of physics, you have to like my video. If you will feel it is helpful for you, you have to subscribe my channel to get the notification of new updates.